Thank you for attending tonight. We welcome anybody that's interested in the general public. You don't have to be a Sierra Club member. My name is Valdi Wiederpass. I'm a volunteer. I serve as chair of Susquehanna Group of Sierra Club. And tonight we're lucky to have Julian Shepherd here, who was a former chair of Susquehanna Group of Sierra Club and a longtime professor. He's going to be talking about climate change. These meetings are free and open to the public. You don't have to be a member, but we encourage membership as it helps us by providing funding, and it lets us know your contact information so we can keep you up to date on important things and let you know when we have meetings coming up and what they're going to be about. So please check your mail for the December newsletter. It's a paper version this time, and on the third page, I believe, at the top is a ballot. So this is going to allow you to vote. There's 5 positions open, and that we have exactly 5 candidates. So we would like at least somebody to vote so that we actually officially get people elected to the executive committee. So please consider voting to show that you are interested and care about who is leading this group. That the executive committee meets once a month. We take 2 months off in the summer, and we decide what the focus of our group should be. We handle the finances of the organization. We sponsor the Move Out project, so we coordinate volunteers for that, as well as the Confluence Park Garden. There's ongoing activities that we do and get involved in it. And we listen to community members too if they have an environmental concern that's coming up that they're worried about. Let us know, and we'll look into it and see if there's something we can do about it. All right. So you should clip out those ballots, mark off, who you're voting for, mail it in, and the date that it's supposed to be in, I think, is the 15th. So mail it before then. Of January. Yeah, January 15th. So thank you very much for that. Also, our September edition is available on our website, as well as the electronic version of the December newsletter is now on our website too, thanks to Maura Ashley, who handles our website. So thank you to her. And if you are interested in writing an essay for our upcoming newsletter, which is going to be coming out in March, please send it to Sierra Club Susquehanna Group at gmail.com. Send it in early mid-February at the latest if you can. 500 words or less. I've said this before, it's a broken record. New York is more than 3 years behind on meeting its 2030 climate goals. It's discussed in the September newsletter, and there's an article about our governor in the December issue as well as a result. Also, I encourage people to contact Governor Hochul's office and urge her to sign legislation that would repeal what's called the 100-foot rule to remove the subsidies that currently charge existing gas customers to pay to add more gas lines to connect any new customer that wants gas service if they are within 100 feet of an existing gas line. Eliminating this rule will end in approximately $200 million per year subsidy, and some years it's even higher than that. And this has fueled fossil fuel infrastructure expansion and burdened New Yorkers with unnecessary infrastructure costs, and it's taking us in the wrong direction as far as climate goes. So that legislation was passed in the spring legislative session, and the governor needs to sign it. We've got meetings coming up. January is going to feature Dr. Thomas O'Brien or somebody speaking on his behalf. Actually, it is him. Retired BU professor. He's going to discuss history of our scientific understanding of climate change and the religious perspective of stewardship of our common garden home spaceship Earth. So it's more of a philosophical exploration of the importance of taking care of our environment and our planet to to help benefit ourselves. February, it's going to be Tom Bolander or somebody speaking on his behalf of the New York State Department of Transportation, talking about the 363 Gateway project and mainly focusing on the archaeological exploration that they had to do prior to starting to actually do the construction of that. And then on March, it's going to be a presentation on Gardening is for the Birds by Karen Anderson and Sarah Hodder, who are master gardeners. So that brings us to a special day. And this day we celebrate Julian Shepherd's birthday. So let's sing happy birthday to him.
Wow!
Happy birthday to me. Happy birthday, dear Julian. Happy birthday to you.
Thank you.
Thank you for being here. And I want to present on behalf of Susquehanna Group. I hope you don't have this T-shirt, or maybe if you do,
I do.
this is an extra one.
Great.
It's celebrating the 125th anniversary, which was several years ago.
Oh, great.
And it's a large. Is that okay for
Yeah,
you?
yeah, perfect.
Okay, good. So I'll show people. It's got multiple insignias as they've
Yeah.
changed throughout the years.
Thank
And I think it's a nice keepsake.
It's lovely.
So
And I try not to accumulate too many T-shirts, but that's a keeper.
and somebody said you wear baseball caps too. So
Yeah.
here's a baseball cap with an
Wow!
unusual one. I'm not even familiar with this
Seal, oh,
Sierra Club seal.
no, but that's a redwood, I'll bet. Or maybe a sequoia.
Yeah. So anyway, so you don't leave here empty-handed.
Thank you. Yeah.
And again, thank you for agreeing to do the presentation, especially on your birthday.
Sure.
So now I'm going to introduce you. Most people know who you are, but
Yeah.
some may not. So we're pleased to have Julian Shepherd here tonight to talk to us about human-caused climate change, which is probably the biggest long-term threat to our future and that of the environment that we need and cherish. Julian will talk about the causes, projections, management, and the impacts of climate change, especially impacts on our natural environment. Julian Shepherd was born in England. He emigrated to the U.S. as a child and grew up in Ithaca. He was educated at Cornell and Harvard in biology and spent 2 years in East Africa on tick research. So that's these 8-legged things that latch onto you and give you Lyme disease if you're not watching, just so you understand what I said.
Pretty good, Baldy.
So anyway, he knows a lot about insects in general. Julian has been an inspirational long-term active advocate for environmental protection and has previously served as chair of Susquehanna Group of Sierra Club. He is also a member of the Commission for Conservation of the Environment for the City of Binghamton. So besides being a professor, teaching students, young people, to be interested in the environment and how habitats work and how wildlife depends on them, he's also trying to help our very own community here still. So we really appreciate that. And Julian, you may now start your presentation. Thank you very much.
Thank you very much. So for my next trick,
So now,
those of you who are here just my
gonna
first
help.
trick, or on Zoom didn't see my first trick. But, well, first of all, actually, I'm in the sort of limelight here. I can't really see all of you, but I welcome questions as we go along, or corrections. I assure you, I'm not lying to you, but you might have some comments on what I say. So do that anytime, but just speak up, okay? And I probably won't see a hand, particularly over this side, so
Is that
just
okay?
butt in. I sort of covered the waterfront here. I do have a special kind of angle on it, though. I think that very many people talk about the human costs of climate change, but they don't really talk so much. Of course we do, but they don't talk so much about the natural environment. So I will hit on that fairly well. By the way, I have quite a lot of information in these slides. I'm not going to read them. Um, please, if you want to know more information now, by all means ask. But if not, this will be available. What do? Do you post it on the website somewhere or?
Yes.
Yeah, okay, good.
Yeah.
Okay, so I will, by the way, restrain myself. I don't intend to, I could probably extend this for a couple of hours, but I won't do that. But do let me know if I'm boring you too. Maybe you know a lot of this, some of this stuff. But anyway, let me start with uh, the causes. And that actually, there's an atmospheric scientist. I'm sorry, I was going to look up his name, but maybe some of you know him. Yeah, that's good. Way back in 1964, who brought this up and said, well, we might be looking at something there. It didn't really catch fire until about the mid 1980s. And probably one of the first manifestations of that was a very good climate scientist named James Hansen gave a presentation to the Congress about climate change and saying, hey, we've got a problem. Notice the date, 1986. And here we are 40 years later. I'll talk a bit about that. But what he was basing it on was, first of all, was one of them was this graph from it came from the Mauna Loa Atmospheric Observatory, and what this is a graph of is uh, the carbon dioxide concentration of the atmosphere as measured on Mauna Loa. Mauna Loa is high; it's up around 14,000 feet, I think, and it's also, as you probably know, the Hawaiian Islands are one of the most isolated group of islands on the earth. And so it's fairly free of sort of local disturbances in the CO2 concentration. CO2, by the way, is carbon dioxide. I'll refer to it either way. So what you see is this graph, and it's beginning in 1960 at around 320 parts per million. And you notice the graph it's not a straight line, it's got a belly in it, and that's because it's continually increasing faster. And we're up around 410 or 415 maybe right now. And so it's increasing. And this is, by the way, the blue line is the average. The little cycles, do you know what the little cycles are? Why it cycles? I blew that up on the right-hand side of this slide. So, what's that? Yeah, it's basically because the northern hemisphere has far and away more plant life, causing the taking up carbon dioxide, and so what you see is that's actually the bottom of that, and then of course when it becomes the season of the southern hemisphere, there's not much forest there, um, so that's why this is sort of a ripple. But thought I'd just show a picture of the wonderful Mauna Loa. It's a very gradual slope up to the top of Mauna Loa, and it looks like it'd be an easy hike, but actually because of that slope, it's a hell of a long walk to the top. And this is actually a picture from the neighbor Mauna Kea, which is now extinct. But it's a very low slope because the lava is so liquid that it runs down a long way. But anyway, that's the mountain. By the way, there's another observatory which some of you might know on Mauna Kea. That's astronomical. It's in the one on Mauna Loa is a atmospheric one.
Julian?
Yes.
Everybody. So a few years ago, Jim Taft was in contact with one of the lead people at Mauna Loa. They were interested in getting more publicity about what they were finding. And we tried to get the local public radio station, I won't mention who that is, to publish that or include it in their broadcast, but we didn't succeed. And unfortunately, I just read that they're no longer being funded to keep track of the CO2.
Really?
So.
Good Lord.
Know that, Jim? Is that right? Okay. Yeah, our funding's coming to a close. Maybe it hasn't happened yet, but yeah. So now it's up to what? What are you saying, Julian? Over 420?
Yeah.
I think it's actually 430 now.
Yeah, this is a little dated.
You've got an older chart there.
Yeah.
Yeah, it's bad.
This is actually the same curve that you're looking at on this slide. But what's also on it is this green line. In about I guess it was about 1985, yeah. Another measuring station was set up off in the ocean here, and it's called the Aloha Station, appropriately enough. But what they began measuring was, again, carbon dioxide, and here it is going right up alongside this one, as you might expect. That's, excuse me, I didn't say, that's the carbon dioxide in the ocean, okay? Quite what that variability is, I'm not quite sure. That wouldn't be anything, of course, to do with forests, but more likely just the seasons, the physical seasons. The lower curve I'll talk a bit about later. Okay, what really alarmed people was that the concentration of carbon dioxide, if you look at it on the longer term, this is over 1,000 years, it was rocketing upward. And what you see is a record of that over the past 1,000 years. With the red on the very far right, that's actually from temperature measurement, and the rest of it is from what they call proxies, things like tree rings, ice cores, and some other things that they use to actually measure what would have been the carbon dioxide concentration then. So I might ask you, Zoom people, is sound and sight coming through well to you? What do they say? Oh, well.
Yes.
Okay. Well, good. Anyway, they called this the hockey stick, and I thought that was a rather cute designation. That was the last 1,000 years. This is the last, what was it, 400,000 years of, again, using proxies. What you see is quite a bit more variation. By the way, that last 1,000 years is all the way over here on the right. So, you see it rocketing upward. What this simply shows is that the concentration of carbon dioxide in the atmosphere is much higher than it ever has been in the last 400,000. Turns out if you go back millions of years, there was a period in the middle of the Pleistocene, I guess it was, where there was even higher temperatures. But that was way back, and things were very different then. But this is a new peak in carbon dioxide. And it's rising so fast. I mean, if you notice, none of these curves are quite that fast. The slope of this one here is considerably lower than the slope of this one here. So it really is rising very quickly. Okay, what's causing all this? We all know about carbon dioxide. We know it's coming from fossil fuels. Do you realize a very large percentage comes from cement factories? The process of making cement from limestone involves the liberation of carbon dioxide. And smelting of iron because they burn things, produces a lot too. And of course, deforestation from burning and decomposition. Sorry, there's a glitch in in what's on the slide there. Don't pay any attention. But methane has come to the fore as a very major component contributing to climate change, and it's due to livestock. Believe it or not, the fermenting that goes on in cattle and things produces an awful lot of methane, and it's a significant contribution. Wetlands, because they're partly anaerobic usually, liberate a lot, and the same applies to rice cultivation. Or you know how the rice paddies are flooded. Well, it's anaerobic down there. Anaerobic by the means without air, but more or less we assume it's without oxygen. Landfills emit methane, and it's a much lower contribution in number of whatever you want to say, molecules, but it has what they call a radiative forcing, about 25 to 100 times more than carbon dioxide. Radioactive forcing just means that each molecule of methane creates 25 times to 100 times more warming than does a molecule of carbon dioxide. I think that's the simplest way to look at it. So obviously it's important, and it's rising a lot, particularly in the only saving grace is that it actually disappears from the atmosphere or diminishes in a major way over 7 to 12 years. Whereas carbon dioxide, you might as well assume from our point of view, is up there permanently. Incidentally, I was just wondering, what happens to the methane? All I ever see is, it disappears in 7 to 12 years. I can't think but that it doesn't get converted into carbon dioxide. But at least that's a much less radiative forcing gas than is the methane itself. We kind of understand now, predictions. We can't make good predictions, but we understand the contribution of carbon dioxide and methane. What's really up in the air now is the action of various things that get in the atmosphere. Particularly, they're largely called aerosols. Black carbon is something I just learned about recently, but there's quite a lot of that coming from various sources, but particularly from forest fires. And that's becoming a significant contribution. But so does sulfur dioxide. Sulfur dioxide comes from volcanoes, but it also comes from power companies. And we know all about that in the context of acid rain, but it turns out that in the upper, particularly up in the stratosphere, it is contributing a lot to climate change. And these, by the way, aren't necessarily always negative, but the problem is we don't really know too much about what they're doing. And that's what researchers are really trying to model these days. And water vapor. Turns out low clouds, of course, prevent the sun from irradiating. And I'll talk about that in a minute. But that saves us some heating. But it turns out the stratospheric clouds, or high clouds anyway, the cirrus clouds that you see, those actually enhance climate warming. And they're just not sure how much. They can't exactly predict how much aerosols are doing or how much they will do. So that's sort of on the front of climate change research. Okay, I thought I'd just say a brief word. I don't want to get too much into physics here, but maybe some of you will appreciate that. But anyway, the idea is that incoming visible radiation gets absorbed on the Earth, but it gets re-emitted as infrared. And I'll bet most of you have heard of that. But the problem is that the atmosphere is generally permeable to visible light, but not to infrared. That gets absorbed by the atmosphere. And what this graph is here, and don't worry too much about it, but it's what they call transmittance of the atmosphere. And what you can gather from it is in the visible range. And by the way, this axis is wavelength of light. So the visibles goes right about up to here. They've got it marked here. And there's pretty open to visible light, but this is all the infrared region. And what this represents is there's very much less transmittance here. So that's the problem, and it's called, of course, the greenhouse effect because of that. Because light comes through the windows of the greenhouse, but it gets radiated as infrared and doesn't go through the glass. So the atmosphere, stratosphere, whatever, is actually working as a sort of greenhouse window. Thanks. If you remember, some of you, back in the 1970s, 1980s, we were worried a lot about the chlorinated hydrocarbons that were coming out of refrigeration devices. And that was actually causing a lot of climate change. This graph, by the way, and I won't be old graphs, I'll show you some pretty pictures later, but it's a graph of sort of the annual increase, okay? Remember, it's not the total concentration, but the annual increase. And the annual increase was increasing very much here before about 1980, 88 to be exact. And it's because of this red component, which was these gases. There is a wonderful agreement, about only the last wonderful international agreement, in Montreal in 1988, that where the scientists got together with the policy people, and everyone agreed that we had to do something about it. You might remember the ozone hole over the South Pole that was spreading, and it was approaching Australia and New Zealand. So, but they reached an agreement to begin to limit the chlorinated hydrocarbons and replace it with refrigerants that were less climate active, shall I say. And what you can see is that that created much less, if you can see my cursor here, much less increase in the, still increasing, but much less increase. And so that's the red component there. And you see it's practically disappeared now. And it is, I mean, there's still chlorinated hydrocarbons up there, but we've got a long way. It's called the Montreal Protocol because that's where they all met in 1988. But what's particularly nice about it is that it's a model of how we should do international agreements. And I'm sure I would be joined by lots of people if I just say that we've never repeated that kind of international success with an international agreement. And so it's still climbing. These lines on the right are different projections of what's going to happen. And what this came from the Hanson's laboratory. And what they're saying is that basically we're on the most pessimistic projection that was produced by the IPCC, which just remember that, I'll talk about that briefly. These are other projections of, this is the one that we should have done, and these are a couple that they hoped would be done. And, and I'm afraid the carbon dioxide concentration and other of these climate change gases is still increasing. In spite of the wind solar is doing a lot, but just in the aggregate, we're still going up. And we should remember that.
Before you go, can I ask you a question? Methane here is the dark blue. And I'm wondering, do you know why methane was such a big component up until like around 1988, and then it got, much reduced, and now it's starting to grow again? What was the reason why we had so much more methane forcing back in the...
As I like to say to my students, Valdi, that's a very good question.
It's what's made for homework.
Yeah,
I just noticed that. I've seen this graph before because I get James Hansen's emails, but.
yeah, no, that's
I was
interesting.
thinking about the methane here.
Yeah. By the way, keep in mind that increase is a relative term. In other words, the total emissions were quite a bit lower here. So think about that. It's a relative term. It definitely is increasing now, and that's why people are particularly worried about methane because I'll say something about where it comes from. Yeah,
Sorry,
yeah.
what's RCP stand for?
Relative climate projection. Okay. And that comes out of the IPC. That may not be exactly correct, but I've got it written in here later. So in other words, it's just what models tell them where that's going. I just saw this a couple of weeks ago in Nature magazine, but a nice projection of what's happening in the United States. This, by the way, and you might say, well, this is kind of nice. This is the total annual emissions in the United States, and it actually has been decreasing ever since, according to this, about 2005. So we're doing okay, but the trouble is, at least relative, but we're still the second largest source of carbon dioxide. But what's happening now, and by the way, that's the darker gray area over here, is that this is the black is what we promised to do by 2050. Yep. These are what the Biden provisions did. You know, all these things like electric cars and had limits on emissions by vehicles. But I'm afraid the Trump projections are now looking like this. So I just thought that was an interesting projection, and I hadn't seen that before.
Yeah, the dark blue was a result of the two main things, the bipartisan infrastructure law and provisions from that incentivize electric vehicles and charging stations and things like that. And then the Inflation Reduction Act, which had huge amounts of tax related incentives for renewable energy and transmission and energy efficiency programs of all kinds, which the Trump administration is now rolling back most of, if not all of them, unfortunately.
Yeah. Okay. Those were the sources of what's causing the problem. I thought I'd talk a little bit about sinks because they're the other part of it. A sink, it's just something that's reducing the carbon dioxide concentration in the atmosphere. And the biggie is plants. They're the only effective way of removing carbon dioxide from the air in the terrestrial environment. And we talk a lot about carbon dioxide sequestration by human engineering, but frankly, that's nowhere yet. There's a lot of pilots, but they're just, we're not doing very much at all there. And I don't think it looks very optimistic either at the moment, because the simplest thing is just pulling it right out of the air. And look, it's distributed hugely in the air, and you've got to concentrate it all the way down, and that's inevitably energy consumptive, so producing more carbon dioxide. So anyway, and of course, the main plant areas on Earth are the tropical forests, and they have been a major sink for carbon dioxide. Unfortunately, they're declining for various reasons. This is just a graph I ran into recently. Sorry, I apologize a little bit for being so heavy on graphs, but they really tell you things. What this is the world's forest's ability to actually sequester more carbon dioxide is decreasing. And this is a graph from 2000. Sorry, I probably need to read this for you. 2001 to the present. And unfortunately, what you can clearly see, and by the way, this is a negative graph because this is a sink. In other words, there is a lot being more sequestered by forests in 2001 than there is now. That does vary with the forest. The Amazon is getting close to being a net producer of carbon dioxide. But the forests of Africa, actually, which have been largely ignored until quite recently in the Congo, that's the second major site of tropical forests, are doing better. They're still increasing in their ability to absorb. As the forests get older, they get bigger, trees get bigger, and they absorb more. But, they're doing their bit to begin chopping down trees too.
The environment shows now maybe 2 or 3 gigatons removal, but the input of carbon dioxide to the atmosphere is now well above 32 gigatons. So this is relatively important, but it's nowhere near the amount that we're adding every year. As you point out, what we add stays there forever for us.
Yeah, so good that you pointed out. I was thinking of saying it, but I already said so much. But so this is a really scary graph.
Yeah.
If you don't understand what's going on here, we have basically because of the problems with the forests having, they're experiencing more heat waves, more droughts, so they're drying up. People are still cutting them down, and they are burning.
Yep.
And a lot of that is driven by climate change. When you dry out the forests and when you have warmer winters than they used to have, the invasive pests attack the trees more. They're more vigorous and they kill the trees more. So the fires burn more hot and catch quicker and go tree to tree more easily. And they stay, many cases, even through the winter and in the northern forest where nobody can get to them. So this is a super scary graph now that we've gone down from 10 gigatons removal down to just 2. So it's 1/5 of what we used to have just 24, 23 years ago. That's horrific and frightening.
Yeah, I was amazed at this. Yeah, I didn't. Thanks. Good. But I was emphasizing tropical forests. Don't forget that the whole plant world is absorbing carbon dioxide. It's just the tropical forests are doing it more and more intensely than most other habitats. But don't forget, urban forests are important too. And we do work on including those, and planting trees anywhere is pretty much a benefit. I'm sure there's some more to say about that, but let me turn to the oceans. The oceans are another major sink. The oceans have been absorbing about 50% of human caused emissions. Notice that's still 50%. That means another 50% they aren't absorbing, but it is declining now. And actually, this turns out to be the real first tipping point in the natural environments. Coral reefs, particularly in the tropics, are the most productive parts of tropical oceans, but actually distributed through the oceans, there's lots of tiny little algae, which actually in the aggregate are doing a huge amount of reabsorption of, or absorption of carbon dioxide. But unfortunately, the coral reefs have reached a tipping point. They're due to their very low sort of temperature sensitivity. And let me just show you that. I think that's actually, let me defer talking in detail about that a little further along, but I will talk about that. But they're reaching that tipping point right now. And and that's not to sort of, by the way, just once again, neglect the effect of the distribution of small microorganisms all through the oceans. After all, 2/3 of the Earth's surface is covered with oceans. Okay, there are uncertainties with, of course, all these projections about, how much is being remitted, how much is being absorbed. And that gives food for the doubters. And by the way, among the scientific world, the number of doubters is down to less than 1%. So don't believe anyone who might tell you from Washington, I can't imagine who that would be, that there is no problem with climate change. It's happening. But there are uncertainties. And by the way, if you ever want to read a good book, I've got it written up there, Merchants of Doubt by Naomi Oreskes and Eric Conway. It's actually 8 or 9 years old, I think now, but it's a great lesson. The merchants of doubt are all the people who are advocating against things, and they particularly take up the example of tobacco and of tobacco, and I was thinking of something else, but they talk a great deal about that, about the obfuscation, in other words, the casting of doubt on the medical effects of tobacco, which are now very clear. Anyway, the answer to all this is to do climate models, and they've been doing that ever since the 1990s. They're the basis of all these projections, and they're getting better and better. You know, we're getting bigger and bigger computers for one thing, and or more competent computers, and so they're getting better, and they know a lot more. But you might be, I didn't know this until recently, but there's now a whole science called attribution science. And you hear it a lot now. You didn't until a couple of years ago. But what they can say is, oh, there was a flood in Western Canada. We were talking about that, Vancouver or whatever. And they can now say, well, yeah, this is part of the natural variation in climate, but or weather. But they will say X% of it, maybe 10%, maybe 30% is due to climate change. And they're getting much better at that. And you know, these are scientists, so they tend to be hesitant to overdo it. And so I think you can trust many of these reports now of either, you know, weather events, cyclones, or hurricanes, or fires, or flooding. And when they say, oh, this is X% due to climate change, they're getting much closer to the mark these days.
So Scott's question is answered there. Representative concentration pathways is the RCP that you were asking about earlier.
Thank you. Yeah, okay. Yeah. That was hatched by the IPCC, which I keep mentioning, but I'll talk about it a little more. This is all the consequences, of course, and these are pretty well known to you, so I'm going to skate over them a bit. This is just the temperature change to 2080, and basically what you can see is that the Arctic, by the way, this is the old Mercator projection of the world, so it emphasizes the poles and de-emphasizes the tropics. But it looks like the whole, you know, a quarter of the world is warming, but it's not really. But it certainly is strongest up in the Arctic, and I'll bet you almost all of you have heard about that, so I won't.
Degrees C?
Yeah.
Yeah.
So they've got there, it's about 12 degrees C raising by 2080. This is probably one of the less optimistic projections, but it's happening. We know that. It's also, and by the way, that's fairly easy to project in terms of modeling. What's not so easy is precipitation, but here is a rendering of what we expect to see in that. Let's see, I thought I would give you the dates. Up to 2100. And this is a pretty rough projection, but it does say that, look, you know, that those places that show brown are going to experience very likely less precipitation. And there are some that actually look like they're more. And if you're a good geographer, you'll say, holy cow, the Sahara is going to be wet. But consider what the Sahara is starting with. They have about 1 or 2 inches of rain a year on average. So if they have 100% increase, that's 2 to 4 inches of rain.
It's gonna be a desert.
Yeah, but the places that are in most sort of in line here is the Mediterranean region, the northern South America here, and actually up into here. And as far as we're concerned, this whole western, excuse me, of the U.S. is likely to experience some drier conditions. Likewise, Southern Africa, as you can see there, and Australia. And we kind of know about Australia. I mean, they practically burned up the continent a couple of years ago. Summer sea ice is going down, and this is a graph. Starting about 1980, it looked pretty constant until 1980 or so, but it's been going down. And here's just a picture of that. Now that they can take sort of big satellite pictures, this is a view down on the North Pole. And I don't need to do much of the geography to tell you that in 1979 on the left, it looked like that. And this, by the way, was the minimum. The minimum in the Arctic occurs around September, by the way, because there's a distinct lag. And but there it is on 2010 on the right. Glaciers are receding. This is the Muir Glacier, which is up in the, trying to remember what it's called, north of Juneau. There's that wonderful national park, Mount St. Elias. Someone tell me the name. Anyway, this is a famous one. I thought it was nice to bring it here because it was the one that John Muir described in his travels in Alaska. And every one of you knows who John Muir was, right? Okay. Anyway, sometime around 1900, this is what he saw on the left, and what we see now is there. I mean, this is from the same place. You can kind of see more or less. And the glacier is now back up in this remote valley here. We're hearing a lot about sea level change, and I thought I would just put some numbers on that because this is the change from 1900 to shortly after 2000, and sea level has been increasing. And once again, it's one of these curves that curves upward like this, or however you're looking at it. So it's increasing faster. The total here is only about 200 millimeters. That's what it is. 200 millimeters is about 8 inches. And you would say, oh, geez, well, that's no problem. But it is in Florida, Texas, and actually along by sort of the eastern end of Virginia and North Carolina. They're seeing the impact of that. It makes higher tides. Nice. Here's a picture of a residential area, and I particularly like this. This was near the coast, and I think it's Florida. You can probably see some palms there. But anyway, and I love the sign. If you can't read it, it says apartment for rent. Let's see if I can read it. Yeah, it says water view among other things. I love it.
Well, because the tides are coming in, they're putting houses all up on pillars. Because it's just washing away.
Yeah.
And that's in Massachusetts.
Yeah. So yeah, the tides, it just, as I said, you don't think it makes much of a difference, but these places are, 5-10 feet above sea level. And so if they get 8 inches higher tides, that's invading a lot of areas.
And that's an average too, what that graph was.
Absolutely,
the sea level
yeah.
rise is not even every place, because some areas, when water heats up, it actually expands. So you can have locally more higher sea level, it sounds counterintuitive because when you just take water in a tray, it's level, but on the planet, it's not level. So it really is different place to place.
Yeah.
And the other thing that affects it is currents too. So if you slow down the Gulf Stream, that local heating can actually end up with some more rise along the shoreline there too. So that's why Florida's having more trouble.
Yeah. Yeah, and it's a little more complicated than you might think too, because actually, do you know that part of the particularly the northern United States is actually rebounding from the glacial era? The land is actually rising, and so that has I think part of the problem in the Carolinas is the fact that it's sinking there.
That's the other thing, yeah.
Yeah,
The
but
South Coast, the Gulf Coast is doing a lot of sinking too, so that's the other problem.
huh. Yeah, so a lot of this is due to just the expansion of the ocean as it heats, You heat anything and it expands. So you heat the oceans, they expand. But it's also due to generally sort of more influx of water from the continents. This is New York City in a few years. It's not, but it is New York City, obviously. But most of you guys will orient to where that came from, Mad Magazine. But there she is. Actually, I have to say, I saw another more recent cartoon of what our dear Statue of Liberty is going, and she was leaving probably Jones Beach or something, and she was halfway out on the way out to France, back to France.
Yeah.
And you can understand why the cartoonist may have called that a political comment. Well, effects on terrestrial biodiversity. Ranges are shifting north, and let me tell you about a few rather interesting ones. This on the left is the giant swallowtail. When I was a kid collecting butterflies, and I don't really do a lot of that now, but I work with butterflies and moths. But anyway, it never was up here in those areas. As Valdi said, I grew up in Ithaca, and what you see on the right is just the reports of giant swallowtails at the north end, and very stable here up until about up until about 1995, roughly, and then it started increasing. And now we see these all the time. I was at the Porch Fest in September last year, and there was one fluttering around on Seminary Avenue in somebody's garden. Now, there's an interesting, just one thing there. They feed exclusively on citrus family plants, so they're moving north, but there are very few here. There's only 2 native species in New York State, and neither of them occur here. I don't know what these caterpillars of these guys are feeding on. Well, I do know they're feeding on garden plants, but because there are some members of the citrus family. But that's just one impact sort of on species. Here's another one. These are tree swallows, very common here, and always have been, as far as I know. But just look at the top graph. That's the date after January 1st that they begin laying eggs. And what you can see is that's declining. And if I look at the axis here, it's gone down about 10 days over 30 years. So, they're adjusting, but not everything can adjust. Here's one example of that. And, oh, sorry, we skipped a slide, a cute slide. Oh, what happened to my slide? Oh, well, don't worry about it. We'll probably hit it later. No, it's not there. I think I misplaced it.
Oh.
But anyway, look, this is another graph of just what's happening with And by the way, one reason I show you so many graphs is because this is the science behind it. And that's what I'm trying to get to you. This just measures incidents like the giant swallowtail or the tree swallow, which have become earlier or later in the era. And to the left is earlier and to the right is later. And what you can see is that there's much more to the left here. In other words, all sorts of things are happening earlier. And a lot of us are aware of that because you watch the spring blooms or the leafing out of the trees or but one thing is actually dangerous to us, and that's the northerly migration of disease organisms. These are two species, and sorry, some of the print got this is taking. I don't know, maybe no. Okay, there's some print. Anyway, this is the yellow fever mosquito, which is the worst thing in the world. And this is the tiger mosquito. Both of these are vectors of, vector means carrier, of yellow fever, dengue, Zika, chikungunya. I love that. And one more. But I outline those on these slide here. Yeah, the other one was West Nile, which we've experienced. What I've got here is just the ranges of these mosquitoes. This on the left is the yellow fever mosquito here, typically tropical or subtropical, and was never a problem up here in the past, except interestingly for boats that came in carrying mosquito larvae in their water barrels. Philadelphia was evacuated during the Constitutional Convention because there was a big epidemic of yellow fever, and yellow fever is horrible. It's got a very high mortality, and you vomit blood, just to make it rather graphic. But anyway, the projection over here on the down here of the yellow fever mosquito by I don't have a date on here, but it's projected to increase until it's actually as far up here as the southeastern New York, New York City. Now, this was on this side was the tiger mosquito, and it was introduced actually down here, and I love that story. It was introduced in Louisiana on old tires because that's a great place for mosquitoes to breed. Have you ever tried to empty a wet tire? If you're picking up on the riverbank, it's almost impossible. Because they hold water so well, and they're dark. Anyway, the tiger mosquito lives in that kind of environment, and it also communicates all those lovely diseases that I list on the left there, and they actually are already recorded in southeastern New York, and I actually did some surveys for the health department 8 or 10 years ago, quick surveys, didn't find any, thank you. But, and somebody more recently told me they hadn't recorded them in upstate New York yet. But, by the way, the mosquitoes don't necessarily communicate these diseases. By the way, we have mosquitoes that are very competent to transmit malaria, but fortunately we don't have the little parasite that causes malaria. So, you can have the mosquitoes, but they won't necessarily transmit. But these, by the way, are all viral diseases, these diseases that I list on the left here. And that we're vulnerable to West Nile. And dengue is a nasty disease. It's not usually lethal, but it's called breakbone fever. Yuck. Your bones feel like they're breaking. That does not sound comfortable. Okay, this is a picture of some of the most endangered birds in the world, the Hawaiian honey creepers. And this is 10 of about 50 species that were known in the recent past. they are becoming extinct. This has 10 species of them on here. 2 of them are labeled extinct, but I can tell you that since this, I think I picked up this slide somewhere about 20 years ago, but 2 more were just declared extinct last year. So 2 more of these. There's very few that can survive the attack of mosquitoes, and that's the problem. Mosquitoes didn't used to be. Oh, by the way, this is a lovely one called the Evie, and what's happened to them is the ones that have survived, with 2 exceptions, have been driven up to the cloud forests at about 5,000 feet here because of the introduction of avian pox and avian malaria, which are absolutely lethal to these birds. And what this shows you here is the abundance of birds here in blue, okay? So they're all right over, this is 1,500 meters here, and that's about 5,000 feet. But they've been decimated, and they were down here. But this is the graph showing the incidence of the mosquitoes here. And the mosquitoes don't do well. Now, the problem with climate change for these is, guess what? It's warming up, and therefore the mosquitoes can get higher. And so it's threatening these birds up in the cloud forests there at 5,000 feet. And that's why they're still going extinct, despite actually magnificent efforts to try and save them. And they've got a new one. Actually, it's a little bacterium that they incorporate into male mosquitoes, at least the male mosquitoes, and sterilizes the females. And we're very hopeful for that. They're doing releases already of these in the Hawaiian Islands. But, you know, that's pretty problematic. You got to have the drones or the helicopters to do that. And it's a big effort to raise the mosquitoes too that are infected with this. So, but anyway, there is a hope for these guys, but it's not appearing yet, I'm afraid. Okay. Oh, this is the slide I said was missing. All I wanted to say here, and don't bother about all the verbiage, but this is a European bird, and it was the subject of a careful study. That's why I put it on here. But they live in the green area of Europe here, but they overwinter in Africa here, mostly right down here, but quite a few in this area. This, of course, is Sahara, not a very good place for flycatchers. But anyway, what they observed was that that the seasons of insects in Europe were getting earlier and earlier, which I showed you a little while ago, you know, by several weeks. And what it turned out was that at least one population of these flycatchers were overwintering in Africa, where the impact, this seasonal change, wasn't apparent. And so they were coming back and finding that the insect burst, which happens, by the way, right around bud burst, you know, happens around here too. You get lots of insects emerging because young leaves are easier to digest. And so you have a big burst of insects. And what was happening is the birds were arriving too late. They depend upon this burst of insects in the late spring to actually feed their young. And the population went down by about 90%. So, you know, that's another manifestation of this change in seasonality, which can affect species in different ways. But in this case, it turns out, actually, this was a study of 20 years ago or so, but turns out the birds actually are learning. In other words, they're adapting. The ones that come back too early are actually profiting. And they're showing that, of course, those are the ones that survive, you know, survival of the fittest and all that.
Julian?
Yeah.
Flycatcher, because we can't see it on the screen. Good.
That's a pied flycatcher, and it's a European one. Yeah, we don't have it here, but it's well known in most parts of Europe. Oh, I should say a little bit about marine biodiversity, and that's where, because this is pretty important. sea level rise, what it's causing here is the disappearance of salt marshes. And, it's pretty apparent why this is. By the way, this is all salt marsh down here, and this is a little tidal feeder creek, and a feeder creek, and it's not a creek down there, it's a creek down there. But anyway, this is all, and this would be flooded at high tide, okay? And you might say, well, okay, sea level rise, the sea marshes, salt marshes will simply move up, but they don't actually. They do a bit, but usually the hinterland behind the salt marsh is a rise, and it rises, and basically we're losing salt marshes. And I think I won't do that, but this is a cute little sparrow, and it's not one you know, probably, unless you've been to the seacoast. It's becoming quite rare now, and I think it is actually officially endangered or threatened anyway. But what it tries to do is kind of cute. It lives in an area of the salt marshes where the grass is kind of short, but it never gets flooded until you have the really high spring tides, which occur every month. It tries to fit the whole nest building, incubation of eggs, raising of the young into 28 days, because that's the time between spring tides. And by the time the spring tide does, it'll be flooding their area, so they better get their little birdies out of there. And that's why it's getting very tough on salt marsh sparrows. Okay, I did want to say something about sea temperatures, and I think this is probably the best manifestation. Excuse me, I just need to check my slides here. First of all, that is a coral reef. Coral reefs are islands in the tropics of incredible diversity. I'm sure you've seen videos, movies of them. Some of you may have been there, but one thing I didn't say in one of my previous slides is that all of the coral reefs in the continental United States, 500 miles of them along the Florida coast, basically. There aren't many. I suppose there's a few down by Texas, but it's mostly Florida. But that 500 miles has now been declared, and I read this just in last year, functionally extinct. And what that means is that it's no longer building or thriving. And the problem there is that two of the species of corals, for those of you who know them, are called the staghorn corals and the elkhorn corals, which are the sort of the basic corals that create the reefs. So do other things like brain corals, and they're doing all right, but the staghorns are not. And what happens to them, by the way, is they bleach. And on the left, what you'll see is a bleached coral. What corals do when the temperature gets too high is they eject little tiny algae, which live inside them and photosynthesize, okay? So they actually produce food for the corals. And I'm not sure they know why corals actually eject them, but they do that. And that removes a major source of food for them. They actually have a way of collecting food too, but bleached corals happen after a big temperature rise, and they will recover because they have some viability left, some of them, but a lot of them, especially if it's done in repeated years, will just conk out. And that's what's happened with the elkhorn and staghorn corals. But it's amazing to think that all of our great reefs around Florida, there's a whole state park down there called the Pennicamp State Park, where you can go out and look at a really fine coral reef where you used to be, but it's frankly dying. So that's kind of too bad. And that's why I call this a tipping point. And I'll just show you what that is here. Another graph. It's sea temperatures, okay? Here's sea temperatures from 1860, okay, way back. So gathered by proxies. But it began climbing here seriously in about 1980, I guess you'd say. And it's now here, right about here, This is about 2025. So all this is projection, but what is happening is it's going beyond the temperature threshold for these corals. And so what this predicts, frankly, is that the general health of coral reefs around the world is going to be greater than the temperature here by 2100. And that's going to sock a big hole in biodiversity on the Earth. And there's a bleaching event that occurred in the biggest reef in the world, the Great Barrier Reef in Australia. This is about 1,000-mile stretch here, and you might guess from this is that the red part is where the bleaching event, I think this bleaching event was around 2023, if I remember. It got really hot, and it simply bleached all the corals up there, some of them here, and this area was unaffected here. This, by the way, just so you know, is the northeast coast of Australia, all the way up to the tip here. And Cairns is here, and just looking for some of these others you might know. Mackay is here, and Townsville is here. So a lot of the Great Barrier Reef. And by the way, that's a great tourist attraction for Australia. So that's suffering, and it's bleached since too. So overall effects, we're losing lots of populations, and I'm sure you've read about sort of, I think it was about 23% of our bird populations are down. By the way, that's the whole population. That's not all due to climate change. A lot of it is just due to human commandeering all the habitats that birds infect. And, you know, another one reporting butterfly populations down. But certainly the climate change has had a big part in that. So I think I'll skip over some of these. I don't want to keep you forever. But just keep in mind that I've been talking about particular species or populations, but we derive a lot of what they call ecosystem services from the environment. And do you know one major threat I'll tell you about is in the South Asia here? You know the populations of India are huge, and China, and likewise actually in what used to be called Indochina here. They are all fed by major rivers coming out of the Himalayas here, and the glaciers are all melting in the Himalayas, which is what feeds these huge river systems like the Yangtze, the Yellow River, the Mekong, the Ganges, and many others. And they all come out of the Himalayas. And this is going to create very serious drinking problems and just water problems in general for all of these huge billions of population that live there. So, and the climate sort of, if you like, the ecosystem service there is the continual production of fresh water from the glaciers, which is going to disappear. And here's another effect. I think Valdi was bordering on this, but the western pine beetle, we don't think much of the western pine beetle here, but it's had a major impact on forests all through particularly the Northwest and up into Vancouver, British Columbia, and up there. And what this is a picture of is in Yellowstone. And here, all of these are conifer forests. Most of the forests in the West are conifers, so they're evergreen all year round. But so if you see a brown area, as you do here, that's dead forest. And it's been caused by the western pine beetle, which has spread dramatically in recent years and actually has decimated some of the logging harvests, but is having some interesting effects too. I'll just have to tell you one because it's so kind of obscure, but grizzly bears in the Rocky Mountains depend upon a high altitude spruce to get pine nuts in the fall to fatten up on. And it turns out that all of them are dying from western pine beetle damage because the pine beetles can now get up to the high altitudes. So, oh well, I think I'm going to just give you a very brief overview of what we're doing, because it's not all misery. There is the Intergovernmental Panel on Climate Change, the IPCC, which I've referred to. They're doing major reports roughly every 5 years or so, coming up with these great models. It's a congregation of thousands of scientists with, of course, smaller panels, but which are actually modeling what's happening. And they're telling us. They finally, actually, they used to say, well, it looks like we're getting some climate change. But in 2018, they came out with a report which said, hey, we have climate change. This is what it's going to do. And so they are the sort of, an overused term these days, the gold standard of what we know about climate change. And but there's other things too, and I mentioned the UN Framework Convention on Climate Change, which was instituted in Rio in 1992. But that's where all nations, actually over 195 of them, got together and said, we're going to do this about climate change. And there were a couple of seminal meetings every year. The parties to this meet, and that's what this is, Congress of the Parties, that in Paris, they decided they really had, each nation had to put forth a program for reducing climate change, mainly reducing fossil fuels, but not exclusively. And but that was a landmark. I mean, this was at what, 20 years after they first became obvious this was going to happen. In 2023, they finally mentioned that fossil fuels must decrease. Okay, that was a bad word, you know, because places that are all these big producers of fossil fuels refuse to use the word fossil fuels decrease. And what happened, I'll have to tell you, this year in Belém, Brazil, is in spite of huge efforts, they couldn't even mention fossil fuel decrease in their final message. And they weren't going to be able to say anything until Saudi Arabia at the very last minute said, okay, you can call it the UAE, the United Arab whatever, sorry, agreement that happened in 2023 that did mention fossil fuels. But they said, okay, don't mention fossil fuels. And so that was somewhat of a, but basically, Congress of the Parties 30s was a pretty bad failure. But there's good things there. Brazil has initiated a tropical forests forever facility, which they want billions of contributions for. And they've actually got 7 billion so far. So that's a facility which is going to aid in all efforts to restore tropical forests. Okay, I've really got to quit. Reggie, you know, the answer to national, what shall I call it, paralysis is that we can have states agreements. And this is RGGI, Regional Greenhouse Gas Initiative, of which proudly our New York State is a member, and they make statewide commitments to reducing fossil fuels. And there's all sorts of ways, and I guess I really don't want to take up the rest of your time, but we can sort of look for solutions, but we can, and I think I'll just end with this. These are my solutions for preserving nature. Practice intelligent, critical, sustainable lifestyles. Have you ever heard of that before? I know you have, but anyway, this is partly what I devised for my students too. They need education, you know, And also educate about ecosystem services. People always say, oh, well, this or that butterfly is disappearing. But there are all these ecosystem services, which I didn't go into in detail. But just think about sort of what wetlands do to mitigate flooding, well, there are a lot of other things. Emphasize science-based evidence, for decisions. That was one criticism of COP30 that took place, was that they really didn't have scientists at the top levels. It was mostly all policy people. So they've resolved to put more scientists up there, because the policy people tend to, ignore the science to some extent. And one thing that I think is good for us is to soft pedal doomsaying, crisis, catastrophe. If we emphasize those too much, it causes certain deafness in a lot of people. And they say, oh, you got another catastrophe? You had one last week. But so just keep soft pedal doomsaying is what I say. And work with economic and social interests. And certainly the Sierra Club knows that. They've adopted in recent years, environmental justice a lot, which used to be hardly ever mentioned. So, and of course, what's great about the Sierra Club is that we're not tax exempt, so we can take well, you can do that as a tax exempt, you can take legal action, but we also can make political recommendations as well, which is something that tax exempt organizations can't do. So anyway, I thought I ought to give you a program for what to do, as if you didn't know already. But anyway, there we are. So thanks. I'd be glad to discuss this. And, if you read through this, if you want to and have questions later, just email me and I'll see what I can do. Yes, Jim.
I think there's a hockey stick in terms of human population.
Yes.
And I wonder if how that would fit in.
Yeah, I think you're right. It did hockey stick, but actually it's leveling off now. They're predicting we're going to arrive at a sort of limit of 9 billion. What's that?
I've heard that. I think there was an enormous increase.
Yeah. Of course, the impact of more developed nations is going down now. I mean, the population, everyone's beginning to talk about an economy with too many of people like me and you, Jim, that are in our elderly years. But Africa is certainly, they've got a lot of young people, and same is true in other places. But China's worrying about their population too.
Right. Japan.
And they had this wonderful sort of, or what was very effective, one-child policy, and now they're saying, "Hey, have as many kids as you can, please." So, yeah.
Back to ocean acidification. What are some of the consequences of the acidification besides, I can see how shellfish are going to take a beating as the ocean gets more acidic, but what other effects are there of the increased acidity of the ocean in terms of marine life, plankton and things like that? Would ordinarily be soaking up a lot of carbon dioxide.
So you're asking sort of what are the consequences of ocean warming?
More acid.
As the CO2 gets absorbed by the ocean, its pH gets lower and lower, it gets more acidic. And
Yeah. Oh, yeah.
it has an effect on shellfish, for example. I mean, I think there's an example already in the British Columbia area a few years ago where certain kinds of, shrimp or clams, or something like that,
Yeah.
were able to develop shells because the pH was too low for them.
Yeah.
That was one area, but I'm just wondering, in a broader sense, in the wide open spaces of the ocean, what kind of.
Yeah, actually, I can tell you what exactly the problem is. Carbon dioxide dissolves in water, it creates acid. And what I never got back to telling you about was that the acidity of the ocean has gone down significantly. It's actually, for those of you who know the pH scale, it's only about 1/10 of a pH unit, but it turns out that's a logarithmic scale. So actually the increase in acid in the ocean is about 30%. And what that does is makes it very difficult to grow shells. Coral shells are made of carbon dioxide and calcium, basically. And so that certainly attracts to mollusks. And there's a lot of it's actually calcium carbonate is, limestone affection in the shells of crustaceans too. So, and that's what coral reefs are made of too, is calcium carbonate. And they're finding it difficult to make reefs.
But they're mainly suffering from the heat.
No, actually the acidity too.
Acidity.
Yeah, yeah.
Are there microorganisms in the ocean too that are bothered by the acid acidification?
Another of your very good questions. I don't know the answer. Yeah, I'm trying to think if I've heard anything about that, but I certainly think it has affected them. Most of those things, believe it or not, actually they migrate up to the surface at night, and I think it's a predator thing. When there's a lot of light up at the surface, they get predated, and during the day, so they actually migrate up and down. And I think that's being affected a lot by temperature, particularly since lower down they're cooler. So, but I don't know any data about that. So,
Julian,
yes.
can you speak to the loss of insects?
I can speak to the loss of insect. Yeah, yeah, sure.
Birds are down 25%.
Yeah.
Loss of biodiversity there, but what about insects?
Yeah, actually, it's about the same for insects in general. There was actually a study in Germany where a bunch of, it's a nice story because it was a bunch of volunteer local naturalists who started collecting flying insects back in 1989, and they did it the same every year up until the present. And what they reported about 5 years ago or so, they said, hey, look, over 20 years, we've lost 74% of our flying insects. And maybe I'll just show you the graph because it's, there we go. No, okay.
Is this your last slide? Are you trying to go?
No,
back
it's
or-
it's 5 or 6 slides back.
Oh, so you want to go this way then?
Yeah. Keep going. It's another graph.
Yeah.
Keep going. There we go.
Oh, okay.
Yeah. So are you seeing that?
Oops,
The
just
the
lost-
green is what they found through the months of May through October in 1989. And what they found in 2013 is the small dark green. I mean, this was the first really sensational study. And this was very well, this appeared in a very rigorously cured, what's the word I'm thinking? Yeah, thank you, peer reviewed science. And these were their results, and it was a shocker. I think it was 2018 that this came out.
Wow.
So, but a more recent study of insects, actually butterflies. Why butterflies? People look at butterflies. They actually census them. They don't pay any attention to the little tiny flies or things that run around, or beetles even, but they do butterflies. And there was a big sort of review of that about 2 years ago, which showed about a 25% loss in insects. And that's whole populations, by the way, you know, that's, or numbers, I should say. So,
I've actually noticed a huge decline.
Oh, yeah.
I have noticed hardly any mosquitoes, very few black flies.
yeah,
I mean, it's just like, where are they? You know,
yeah.
You drive
normally,
your car at night and your windshield does not get insects on
yeah.
it. That's weird.
Yeah, yeah.
In the summer, it's just changed.
I still hear stories of people coming back from the Adirondacks in May or June and saying, my God, those black flies are still there. But anyway, yeah,
Locally at least.
Yeah.
Hardly any.
okay. I guess I did run a little over time, but
That's okay.
there's so many interesting stories connected with this, so. Thank you.